So I'm Amudha. I'm working as assistant professor in the Department of Computer Science and Engineering in Bharat Institute of Higher Education and Research, Chennai. So the course today we're going to see is compiler design, and the course code is U18Pccs601. The topic in today's session is Introduction to Compiler Design and the Phases of Compiler. So let's see what's today's agenda. So today's agenda is we're going to see about what is compiler, how it works, and what are the components it has, and what are the features and how it works, and what is the input and what is the output, and how it performs. Everything we're going to see about the compiler. The next is the phases of compiler. So we're going to see what are the different phases of compiler, what are the different operations performed in each phases of a compiler, and how it works. And the next is we're going to see the examples in each phases of a compiler, and what are the input and what are the output, and how the process works, and how it solves an example. So this is what we're going to see in the today's session. So now, what is a compiler? So everyone knows, although people who use the computer often, they'll be knowing it. What is the compiler? So obviously the one who's having a computer, they should be knowing it. The one who writes the program and codes the program and compiles, they'll be knowing what is the compiler. So let's see. So what actual work is done by the compiler? So compiler is a software which converts a program written in a high-level language, that is the source language, to a low-level language in which the machine can understand. See, high-level language is what we can understand. So English language is the high-level language, but the computers cannot understand the high-level language. So it is the duty of the compiler to convert or to make the computer to understand. So it converts the high-level language into the low-level language or the machine readable language. So which means that the compiler converts the high-level language into a low-level language in which the language can be easily understood by the computer, and then it executes, then it gives the output. So see, this is the block diagram or the diagrammatic representation of a compiler. So the compiler gets the high-level language program as an input, and it performs and checks for the compilation error and all the other compilation error, token error, syntax error, semantic error, whatever the error occurs inside this, it just checks, corrects, and then converts into the low-level language. So low-level language is the language in which the computer can understand. So next, so when you go with the compiler, you have to know what are all the language processing system. So the language processing system, which means that the compiler uses, so using the compiler. So we're gonna see. So obviously everyone knows that the computer is the logical assembly of software and the hardware. So what they're trying to say is the computer is a contain of both hardware and the software. So here the hardware knows the language, so which is hard for us to understand. Obviously, we tends to write a program in the English language, that is the high level language, in which that is complicated or complex for the machine to understand. So now, with the help of these, what we do or the compiler do just transforms the high level language into the low level language or in which the machine can understand. So see here, so you're giving the high level language as an input to the preprocessor. The preprocessor gets it and just gives into the pure high level language, and that has been fed as an input to the compiler. And this compiler performs the conversion of the high level language into the low level language machine code in which it gets the assembly language that can be easily understood by the machine, and that has been given as an input to the assembler. So assembler gives an output as a relocatable machine code. With the help of these machine codes, what you do, you can able to relocate the code, and then the linker will get the relocatable code and just place its position in the memory, and that loader will help that into places into the memory. At the end, we get the absolute code. So this is how the language processing system occurs with the help of a compiler. So see, we'll see one by one. So this is the representation of the language processing system using a compiler. We'll see one by one each component detailed explanation. So high level language. So if a program contains an hash define or hash include director such as hash include or hash define, It is called as the high-level language. So which means that they are easily understood by the humans but cannot be understood by the machines. So these hashtags act as a pre-processed directive. This explains the compiler or explains the machine to do or to understand what they have to do. Okay. Next is preprocessor. The preprocessor removes all the hash include directives by including the files called the file inclusion. And then hash different directives using macros expansion also be removed. So it also performs the operations like file inclusion, augmentation, microprocessing, etc. So these are the operations done by the preprocessor. So in the language processing system, we have seen with the high-level language and the preprocessor. The next component is assembly language. So in assembly language, it is neither it can be in the binary number or in the high-level language. Then it is the intermediate state in which is the combinations of machine instruction and some other useful data are also needed for execution. So see here, the assembly language gets an input from the preprocessor directive and then it acts as an intermediate of combinations of both machine instruction and some other useful information that need to be executed. Next comes with the assembler. So here, every platform or every computer have the hardware along with the operating system will have an assembler with it. So they are not universal, which means that they have different from different platforms. So obviously the output for the assembler is called as an object file. It translates the assembly code into the machine code. Next comes the interpreter. So here interpreter performs the same job as a compiler, but the problem is that it just reads line by line and then executes. So one line has get read and then it is executed. So likewise, but this is slower when compared to the compiler. That's why we often ignore the interpreter, we go with the compiler. And it is interpreters are usually slower than the compiler. That's why we prefer with the compiler. Next is relocatable machine code. So it can be loaded at any point and can be run. So the address within the program will be in such a way that it will cooperate for the program movement. So see here, relocatable machine code. What do you mean by it? Relocatable machine code, which means that it will be always have the address with it that will help for the movement of a program. Next is loader or linker. So it converts a relocatable code into the absolute code. So which means this is what we want as an output. And it tries to run the program resulting in the error. If there is any error message will be resulted, again it will be corrected. Then, so the linker loads a variety of object file into the single file and makes it executable. And then finally it loads into the memory and executes it. Okay, this is the language processing unit using a compiler. So it contains, see, high-level language is given as an input to the preprocessor, and then we're getting an output as a pure high-level language that has been fed into the compiler, and that gives an assembly language which has been fed into the assembler, and then we get a relocatable machine code in which we can able to relocate, and that has been loaded and a link by the loader or linker, and then we get an absolute code. So that's it for the language processing unit using a compiler. So next is the phases of compiler. So here, so there are two major phases of compilation. So actually the compilation is what done by the compiler. We're going to see what is happening inside the compiler or during the process of compilation. So in which that has many parts but has two main phases. Each of them take input from the output of the previous level and work in a coordinated way. So here what they're trying to say here, see the analysis phase and the synthesis phase are the two main phases. So inside the analysis phase, we have again three different passes. So in which the input is fed into one pass and then we get an output that has been fed as an input to the second stage. So likewise, the input and the output are fed into the consecutive stages and then we get an output. So that is what done by the compiler. So we're going to see with the phases of a compiler. So in the analysis phase, we perform analysis, and in the synthesis phase, we perform the synthesis, and then we get an exact target code. So see, analysis phase. So it is an intermediate representation is created from the given source code. So an intermediate representation. So what are the things it has? It has a lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator. So these are all the phases we have in the analysis phase. So the first phase in the analysis phase we have is lexical analyzer. The second is syntax analyzer, and the third is semantic analyzer, and the next is the intermediate code generator. So we'll see what is lexical analyzer and what it does. See, the lexical analyzer divides the programs into tokens. Okay, so what do you mean by tokens? So individual words or characters. And these tokens are also called as lexemes. So the lexical analyzer divides the program into tokens or the lexemes. Next, syntax analyzer. The syntax analyzer recognizes the sentences in the program with the help of a syntax of a language. So it just checks whether the sentences are in the correct format. Next is semantic analyzer. The semantic analyzer checks the static semantic. Semantic checks for the grammar correction. And then the intermediate code generator generates the abstract code. So this is the first phases, and we have seen only the brief about each phases. So once we complete with the synthesis phase, we'll go with the detailed elaborated explanation and the example and how process happen in the each phase. And the synthesis phase. So this is the second phases of a compiler. So in second phases, here the target program is created from the intermediate representation. So it has code optimizer and the code generator. So what is code optimizer? It optimizes the abstract code, and this code generator translates the intermediate code into the specific machine instruction. So here the code optimizer checks for the abstract code, which means it performs optimization of code which is the best it chooses. And then the code generator generates the code or target code according to the specific mission, target mission. Or see. So this is the phases of a compiler. So here the source program has been fed into the lexical analyzer is the first phase. The next is the syntax analyzer. The next is semantic analyzer. It is followed by the intermediate code generator. Again, it is followed by the code optimizer, code generator, and you get the target program as an output. In all these phases, we have got 6 phases. All these 6 phases are connected to the symbol table manager and the error handler. So this is the representation of 6 phases of a compiler and how the source program is given and how we get the target code or the target output. So here, these phases are connected with the symbol table manager and the error handler. So now we're going to see with the detailed explanation. So in the next slide, we'll see here. So the compilation process is a sequence of various phases. So which means that the first lexical analyzer gets the source code, executes, performs operation, then it gives an output that has been fed as an input to the next phase, syntax phase. So here, so each phase takes the input from its previous stage that has its own representation of a source program and feeds it output to the next phase of a compiler. So next, so this is another representation. This is kept for easier understanding, the same diagram, the source code. So you're getting the lexical analyzer, the syntax analyzer, semantic analyzer, intermediate code generator, machine independent code optimizer, code generator, and machine dependent code optimizer. Now all these phases are connected with the symbol table and the error handler. So next, so this is the basic understanding. See, we are giving a source program or the character stream into the lexical analyzer. We get an output as a token stream because the purpose or the work of a lexical analyzer is to give the output as a stream of tokens. The next is that tokens are given as input to the syntax analyzer. So in the syntax analyzer, we get an output as a syntax tree, and this syntax tree is passed into the semantic analyzer, and then it generates again syntax tree without any grammar error or without any ambiguous. Next is this syntax tree is fed in as an input to the intermediate code generator. So in intermediate code generator, it gives an intermediate representation, which means that these instructions are passed into the machine independent code optimizer. This code optimizer optimizes the code and then gives the intermediate representation of the same code. and that has been fed into the code generator. Here it gets a target machine code, which means that they are machine independent, that has been converted to the machine dependent, and then we get the machine code. Now all these phases will have an error, and they will identify an error that has been connected to the error handler. The same thing, all these phases are connected to the symbol table manager also. And this symbol table manager is used to maintain a record or data of about all these things with the address. And the error handler maintains records of about errors that has been performed or detected in each phases, and that will be stored or referred into the error handler. Yes. So now we're going to start with the lexical analysis. So what is happening in the lexical analysis phase and how we get the tokens or the stream of tokens. So see here, the first phase, so lexical analysis or the lexical analyzer is called as the first phases of a compiler. And here the scanner works as a text scanner. So in this phase, the source codes are converted into the stream of characters, and these stream of characters are also called as meaningful lexemes. Here, the lexical analyzer represents the lexemes in the form of token name along with the attribute value. So the lexical analyzer represents the lexemes in the form of token name and the attribute value. So see here, so when we give as the input, so it takes the source program or the input string as an input, and it gives a stream of tokens as an output. The process is performing is it reads the character in the source program and group them into the stream of tokens. Next, the token name. So abstract symbol used during syntax analysis. Next is the attribute value. It represents the entry in the symbol table for token. So we'll see the example. So see here, this is the string or the character stream I'm going to pass into the lexical analyzer. So the position is equal to initial plus rate into 60. So here this position is considered to be the lexeme, and that is mapped into the token ID, 1. So next is ID is an abstract symbol, and the 1 represents the position in the symbol table entry. Next, assignment symbol equal to is called as an assignment symbol. So it is the lexeme and has been mapped as a token that has been kept inside the arrow marks. Okay. Now, since it is the attribute value, we don't need to consider the symbol table entry. So only the symbols, only the abstract values will have the ID. The symbols will not have an ID. So see here, so initial. So as of now, we have done with position is marked into the token ID, 1, and where ID is the abstract symbol and the 1 represents the symbol table entry position, and the assignment symbol will not have the ID token symbol table entry. So next is initial, and this has been mapped into the token of ID, 2. And next is 2 points is symbol table entry for the initial. So 1 represents the symbol table entry for the position, abstract symbol position. Next is plus is only a lexeme, and it is mapped only with the token plus. So you don't need to have the entry. Rate is mapped into token ID, 3. Next is 3. So this points to the symbol table entry for rate. And a multiplication symbol is token of multiplication symbol. Next, 60. So it is mapped into token of 60. So here, the blank spaces and the lexemes will be discarded by the lexical analyzer. Excuse me. So here, so it was the example was position is equal to initial plus rate into 60. So see here, so ID 1 that represents the position is equal to this assignment symbol is equal to ID 2 is the initial along with the addition operator. Next is with the rate, then multiplied with the 60. So this is how a stream of character that has been passed into the lexical analyzer has been converted into tokens or lexemes. So this is how the lexical analyzer converts it. And this is the output of the lexical analyzer. So next phase. So first phase is lexical analysis, and the second phase is the syntax analysis. If you've seen the second phase, this phase, so syntax analysis. So this is called the second phase of analysis or parsing. and it takes the token produced by the lexical analysis as an input, and it generates the syntax tree or parse tree. In this phase, the tokens are arranged and checked along with the grammar. So if there is any error, that will be checked by the syntax analysis. Next, so it gets the input as a token of stream. The output will be the syntax tree. And what are the process it does? The scan token streams are hierarchically structured into the correct form of syntax tree. And this helps in correcting the errors in the grammar of given tokens. The rules, what are the rules happening in the syntax analysis are, the first rule is any identifier given is an expression, and any number given in this token is an expression. So if you have got two expressions, expression 1 and expression 2, you can add both or you can multiply of these two. Yes, so this is the representation of syntax tree. So when you give an input to the syntax analyzer, you get the output as a syntax tree with the grammar correction. So this is how it will be represented. So the syntax tree is x is equal to y plus z into 50. So here the symbols are made as a root node and the operands are made as the leaf node. So by this, I'm assigning each operand to an ID. So x is assigned to ID 1, y is assigned to ID 2, and z is assigned to ID 3. So this is how the syntax tree is generated. Next comes the semantic analysis. So in semantic analysis, the syntax tree is passed as an input, and then it constructs and it checks for the semantic errors. So for example, if the assignment of values is between the compatible data type by adding a string to an integer. This is what done in the semantic analysis. And the input syntax tree. So the input for this will be the syntax tree and the output will be the parse tree. The process occurring here is type checking, which means this is checks for the semantic or the meaningful error in the syntax tree. And this process is done with the help of the intermediate code generator. So see here, so the same example or the same syntax tree we have taken. So ID 1 along with a plus and ID 2 and multiplication symbol. And here the 50, since this was an integer that has to be converted into real. This is the process of type conversion. At the end, we are coming with the intermediate code generator. So in the intermediate code generator, it represents a program for some abstract machine. And here, the language is in between the high-level language and the machine language. And this intermediate code should be generated in such a way that it makes easier to be translated. Intermediate code generator. It represents the program for some abstract machine. So the language will be in between the high-level language and the machine language. And this intermediate code should be generated in such a way that it can be easily converted into the target machine code. So how this intermediate code generation process? It takes the input from a parse tree and the output will be in the intermediate code, which will be in the 3 address code format. So what are the possible 3 address code formats are the syntax tree, postfix, and the 3 address code. The process done by the intermediate code generator is the compiler receives a valid syntactically and constructs them into the intermediate form. So these form can be in any 3 of the address code. One will be the syntax tree, postfix, and the 3 address code. So next is the compiler must take some temporary name to hold the value that has to be computed by each instruction. So for example, I'm just assigning the 3 temporary variables, T1, T2, and T3. So T1 is assigning to the integer to real value of 60. For T2, I'm just multiplying the third identifier into the T1. That is the first temporary variable. If I go with the third temporary variable, I'm assigning it to the identifier 2 with the addition along with the second temporary variable. So at the end, I'm making the ID 1 is assigned to the temporary 3 variable. So the last process of code optimization, one code optimization is done, then I'll be getting the target code. So see here, so optimization is something that we always remove the unnecessary codes of line, unnecessary spaces, something given in the program, which means that we are removing the wasting of resources And then we use only with the optimized code. So what happens with the code optimization? It takes an intermediate code as an input in the initial phase, and then output will be the optimized intermediate code. It performs the code improvement operation in which it removes the redundant data and elimination of redundant data and the any other unreachable code. So I'm just converting this temporary with the help of temporary variables which have been assigned, which we feel that is unnecessary in that code. We are just removing it. When you see this example, optimized code. So I'm just taking only the temporary variables 1 and 2. I'm not using temporary variable 3. And there is no need for the identifier 1 also. So temporary 1 is assigned with the third identifier multiplied with the 50 value. Again, the second temporary variable is assigned with the second identifier with the second temporary variable. That's it. So at the end, we perform the code generation. Here we get the in which the optimized code is generated into the target machine code, and then where that can be placed into the relocatable machine code. Yes. So the process input will be optimized intermediate code, and the output will be the target code. The process will be the target code may either be relocatable machine code or the assembly code. So here these are the examples for the assembly code which can be easily understood by the compiler, which means that move F, which means that you are moving the identifier into the register 3. Multiplication F, that is MULF, which means that multiplication values, multiplying the value 50 along with the data present in the register. So these are all the machine codes which can be easily understood by the compiler. At last, we're coming with the symbol table and the error handler. So symbol table contain the entry or the position of the each data in the each phases. Next is error handler. So error handler, even all the phases of a compiler will be connected to the error handler. So in each phases, error will be detected and solved that will be stored or the data can be retrieved from the error handler. That's it. Thank you.